All right, guys. So the last part of this chapter before our chapter test. Ooh, before our chapter test. When's our test? It's Friday. It's Friday. The review is due Wednesday because I will not be here on Thursday. I'm taking my personal day away from school to go to another school. My kids have a Halloween party at school, so I'm taking my personal day so I can go and be in the classroom with them on Halloween for their parties and stuff. So I know, right? I take my day off to go to a different school. But that's why the review's due Wednesday, so I can be here to go over it with you, and then the test will be on Friday. I don't like giving tests when I'm not here because for whatever reason, people score way lower when I'm not here, even though I'm just literally in the room. I don't know what it is. It's my presence. You guys just lose all confidence because I'm not like in the room, right? I've had students do that. They raise their hand, I walk over, I'm like, hey, what do you need? And they're like, oh, never mind, I figured it out. I'm like, you standing next to you. It's all of us. All right, so today we are learning 11 to 14, I believe it was, on the review. Like you guys did 9 and 10, which is like that working backwards. And then 11 through 14, you guys were like, whoa. Same idea, still that working backwards, just setting them up's a little different. So today is one of those fun, obnoxious, tedious days. I knew you'd be excited. I knew you'd be excited. So complex numbers, we've talked about these. Complex numbers, it just means it has an I. They have conjugates. They come in pairs. Why do they come in pairs? If I have an I also have negative I. Why? Yes, because I get I from taking the square root. And what do we know accompanies every time you take the square root of something? Plus or minus. So if you have, this is just kind of a textbook definition here. If you have a plus bi, you also have a minus bi. You have the plus and the minus. Same thing with radical numbers. If you have the positive, you also have the negative. So you always have their conjugate, right? They always come in pairs. So again, we just kind of talked about this. Think about how, when we take the square root, we always have plus minus. I's come from square roots. Obviously, if you have a radical 6, that came from taking the square root of something. Okay, so every time you have an I or radical, it is plus minus. So if I give you the positive radical 6, you also then need to realize you have a negative radical 6. You always have both of them. So if a fourth degree polynomial, fourth degree, how many answers will I have? 4. If I told you it has roots, zeros, answers, remember we can use that word kind of interchangeably. If I told you two of the answers were radical 2 and 1 plus I, what are the other answers? Blue? Good. I just need you to start to recognize this thing, right? If I have the positive radical 2, I also have a negative radical 2. If I have a 1 plus I have to have a 1 minus I. They always come in pairs. Could a third degree polynomial with rational coefficients have roots of radical 3 and 2 minus I? Why? Because it says so? Where does it say? Oh, because you said so. Yeah, third degree would have how many answers? That should have 3 answers. But if I have radical 3, I also have a negative radical 3. And if I have 2 minus I also have 2 plus I, which is 4 answers. So is that possible? No, it is not. It would have to be at least fourth degree. All right, what is a third degree polynomial that has roots of 5 and radical 2? So if I have radical 2, what else do you have? I also have negative radical 2. So are you okay if I just put plus minus in front because I'm lazy? Right. If I have, I know a plus minus always attaches to a radical, so I should have both. Okay. Well, we know these. Oh, this is where we work backwards, right? These are my answers. Where does 5 come from? X minus 5. And the million-dollar question for today. Where does plus or minus radical 2 come from? x squared, because there's two answers, so it's going to come from x squared plus or minus. Yeah, both of them. It's minus 2. Stop and think. If I have x squared minus 2 and I asked you to solve that, because that's in essence where this is coming from, think about solving that. You'd have x squared equals, moving that over become a positive, and then you'd take the square root, and you'd get plus or minus radical 2. Okay? So on these, this is where I get frustrated with students when they set these up wrong. Can you check them to make sure you get the answer you wanted? Yeah, you can check them. Set it equal to 0 and solve it, and make sure you actually get what you're supposed to. If I had written x squared plus 2, okay, let's say I messed up my sign, then when I move this, you'd get x squared equals negative 2. And then what would happen when I take the square root? I'd end up with an I in front of that. That's not what I want. Okay, so you need to stop and think. Set it equal to 0, solve it, and see if it works or not. Okay, so that one's not good. What form am I in right now? Factored form. What form do I want? Standard. So we need to actually multiply this together. So we get x cubed minus 2x minus 5x squared plus 10. Is it good just like that? Why not? It's not in order. There's no like terms, but that's not in the right order. So y equals x cubed. There you go. Good. Now before, I kind of stressed to you guys, we want to make sure we graph them. It crosses where we want it to. If I graph that, where is it going to cross? It will cross at 5. That was a nice, pretty answer. What's radical 2? It's not a perfect square, but what is it? But is it, will it cross? Yes, it will cross. Take the square root of 2. Somebody grab a calculator, take the square root of 2. Tell me what it is. Okay, so it will cross at roughly 1.4 and negative 1.4. Not 2. It's plus minus. So it's going to cross at the positive 1.4 and the negative 1.4. Okay, do I need to make sure it's exactly right at 1.4 something? No, but I can quickly look at a graph and be like, oh yeah, look, it'll cross at 5 and about 1.4 and a negative 1.4. It's crossing at both. Write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. That is a mouthful for directions. What's it asking me to do? Put that back into a polynomial just like the last one we did. That is what the directions look like on your test, and I want to make sure you get used to seeing those directions. It's just, here's the answers, put it back where it started from. That's all it's asking for. So real quick, I have a 7, and I have a negative radical 3. Do I have another answer that's not listed here? Yes. So guys, first thing I would do when you look at a problem, if it gives you a radical or an I, automatically I want to see you put that plus minus on it. Because otherwise people are getting confused in their signs. They're like, oh, it's a negative, so it must be a plus. Because it's always the opposite, right? But it's not. These come in pairs. There's always plus minus. So where does 7 come from? X minus 7. Where does plus or minus radical 3 come from? X squared minus 3. And again, if you're not sure, x squared minus 3 equals 0. So you'd add that to the other side. You would take the square root. You'd end up with exactly what I wanted. Okay? Do that double check. Did it take me that long to drop that down? It didn't take long. And some of you just think through it. Some of you can kind of visualize that in your head. Moving it over, taking the square root. Yeah, it's going to work. All right, what form am I in? Factored. I don't want factored. So we will distribute. We get x cubed minus 3x minus 7x squared plus 21. Any like terms? No, but the order's a little messed up. So x cubed minus 7x squared, good, minus 3x plus 21. So again, hard? Not really. I think it's more tedious than anything else. Write a polynomial function of least degree, has rational coefficients, a leading coefficient of 1, and the given zeros. What am I doing? Same thing. Just give it to me. All right, just put it in the right order. If I have a positive radical 5, what else do I have? What symbol should you write in front of this? Plus minus. It's not given, but we should recognize they have to come in pairs. All right, take a minute, work through this one on your own. All right, Jonathan, go ahead and show us how this works. It's all right. I can read it. Good. X minus 3. X squared minus 5. Good setup. All right, so he is distributing x cubed minus 5x minus 3x squared plus 15. Yeah, we don't like that order. So x cubed minus 3x squared minus 5x plus 15. Very nice. Very nice, Jonathan. Now, did everybody notice how brave he was in walking up there? What did he not take with him? He did not take his paper. Most students automatically will grab their paper when they walk up there. Kudos, Jonathan. Very nice. All right, questions on that one? We doing okay? All right, what happens when we have more things to multiply? It is more stuff to multiply. I mean, so I have a radical 2. What symbol goes in front of that? Plus minus. All right, where does negative 3 come from? X plus 3. Where does 3 come from? Where does plus or minus radical 2 come from? So where do you want to start? Yep, absolutely. I'll start with the back 2, just like we, done all the time. So multiplying here, we get x cubed minus 2x. Yes, if you recognize that, that's what I would do. Yeah. Minus 3x squared, not cubed. And then plus 6. Now, I know that's not in the right order. Do I have to put it in the right order right now? No. So then I'm going to drop this one down, and we'll multiply here. Now, Lexi asked the question, she recognized x plus 3, x minus 3, so that came from x squared minus 9. Could she just write that? And absolutely you could. If you recognize it, by all means, it's going to be a lot less multiplying for you. But otherwise, this process, it works. So distributing here, you get x to the 4th minus 2x squared minus 3x cubed plus 6x plus 3x cubed minus 6x minus 9x squared plus 18. Ooh, isn't that pretty? So those of you who have terrible handwriting, yeah, you guys know who you are. Be careful. All right, putting like stuff together, we have x to the 4th. And then, let's see, minus 3x cubed plus 3x cubed. That's nothing. Minus 2x squared minus 9x squared. It's minus 11x squared. And then 6x minus 6x. And plus 18. You could have. Yeah. I know. That's what I would have done. Because I'm keeping it consistent the way I've taught it in the past, is we start with the back 2 and we just kind of work our way through. Because it doesn't always show up where you get the conjugates of each other like that. That's where, like, she's like, I recognize that's x squared minus 9. Great. That's awesome. When you graph this, where's it going to cross? How many times will it cross? It will cross 4 times, right? 3, -3, 1.4, and a -1.4. Okay, so it will cross all 4 times. How are we feeling? Doing okay? I mean, it's tedious, but do we understand? Why don't you guys try this one? All right, guys, pay attention as Savannah takes us through this one. Your sweatshirt keeps hitting the board, your sleeve. Oh, good. She put the x out in front for the 0, not x minus 0, because that's obnoxious. Ah, very nice, very nice. So remember the radical 8? I gave you negative radical 8, but that means that's plus minus. Always put that plus. I know it throws people. They see the minus and they're like, wait, what do I do with my signs? Plus minus. Every I, every radical. Plus minus is attached. Your sleeves. I know. Yeah, I know I've done that before where I just get really close and it like registers it. Hey guys, you're being rude to your fellow classmate. Check your work as she goes. Make sure yours is matching. We'll talk later. All right, so she distributed the first 2, drop down the x, and the x gets distributed. Corbett and Marissa, you guys want to do the next one? Yeah. Be careful on your very last thing with the 16. But be careful, you distributed the x all the way through? You lost your x. Yeah, the back of the pen's an eraser. Yeah, way cooler than the old smart boards, right? Yeah, it's got a mind of its own sometimes. Yeah, it doesn't want to change. That's all right. Go ahead. Yeah. I'll do it. Very nice. Thank you, Savannah. So guys, double check your answer. X to the 4th minus 2x cubed minus 8x squared plus 16x. Beautiful. What was that? All right. We talked a lot about radicals. What about I? They're plus minus as well. Yep. So first thing, guys, again, when you see an I, plus minus is attached. Where does -4 come from? X plus 4. Where does plus or minus 2i come from? X squared plus 4. All right, let's talk, guys. Let's talk. If I would set that equal to 0, x squared plus 4 equals 0, you need to stop and reason through this, okay? So if I would solve this, you would subtract the 4 and then take the square root. So it's plus or minus. That would give you 2i, which is what I wanted. I'm actually taking that square root. Okay. So some people are great at just reasoning through all of this, and that's fantastic. And some of you are going to go, I don't know how you just did that. And that's okay. Let's talk through it. I'm trying to move him, and he doesn't want to move. I know, it looks like I just, like, beheaded him. Forget it. Yeah, it's not. Anyway, all right, so if you have a radical versus if you have I, let's just kind of set up how to do this. That way we're all okay, right? That way, if you can't reason through it, we can memorize, right? One or the other. I like to reason through. Some people aren't so great at it. So if you have a radical, it's always going to be x squared. What symbol? Minus. That way when I move it to the other side, it's positive, so I don't get an I. And then right here is always the number under the radical. Right? You just took whatever number it was and just went with it. But if there's an I, it's x squared and plus. That way when I move it, it becomes negative on the other side. What is this near? Not the square root. You square it. Square the number. Or I could write number squared. Whatever makes sense to you guys. So I like obnoxious, annoying ways to remember things, right? Like the whole toilet paper thing, stuff like that. Some of you still reuse toilet paper, or you don't use it at all. It's really gross. The radical. People use the radical more than once. Were you not here the day we talked about that? Called it toilet paper? But it was gross, right? But you remembered it because of that. The I am a very positive person, right? I am a positive person. I think of things from the positive. I try to see the best in people. I am a positive person. If it has an I, it is a positive. It is a plus. Alvea. I am a positive person. If it's an I, it's a plus. My obnoxious things don't work if you don't listen to me say them. I am a positive person. I see the best in people. I am a positive person. It's a plus sign. Okay? Whatever it takes. I'm just trying to help you remember this, okay? I like annoying, obnoxious ways to remember things. All right, so here we go. Back to this one. So if you distribute, we get x cubed plus 4x plus 4x squared plus 16. And then just rewrite it in the correct order. Very nice. But helping to recognize i's and radicals are plus minus, Jasiri. That helps us remember to put a plus minus in front of it. It helps us remember to put in x squared when we're setting this up, because that's two answers. All right. Oh, that one. Number 9. Where does, well, I is just sitting here. What should be in front of it? Plus, minus, and yes, there's a 1 there. So where does that come from? X squared plus 1. I am a positive person, and then you square the number. 1 squared is 1. And then negative 7 comes from x plus 7. And then we distribute. So x cubed plus 7x squared plus x plus 7. How'd I do what? It's already in standard form. There's no like terms. I'm done. Looking at a graph. Where does it cross? Negative 7. Is that it? Yes, because imaginaries don't cross. So if you graph this and it crosses anywhere except negative 7, it's wrong. Okay? You guys ready to try one on your own? I have her D block. All right, guys. Setting this up. You know we have an I. Guys, I want you to get in the habit when you see the I or you see the radical, plus minus goes in front of it. Okay? Bless you. So negative 5 comes from x plus 5. 0 comes from x in front. Plus or minus 6i comes from where? Good. Every year, I find students who, they do the whole process, they multiply, and they know what they're doing, they just set it up wrong. If you write x squared plus 6, it's going to be wrong. So again, take that extra second to either write it down or to do it in your head. Think about, okay, if I set that equal, I would move it to the other side. Then I would take the square root. Yeah, that would give me plus or minus 6i. Just make sure that you did set it up right. All right, and then we have to multiply. So x cubed plus 36x plus 5x squared plus, is it 180? It was, but I can still do that in my head. And then drop down the x and distribute here. So x to the 4th plus 36x squared plus 5x cubed plus 180x. Good? That's not in order. So x to the 4th plus 5x cubed plus 36x squared plus 180x. If I graph this, where is it going to cross? -5. Is that it? And 0. And that's it. Right? The i's do not cross. Questions on all of this? Are we doing okay? Okay. I will skip that last example. But I want to kind of talk one last thing, kind of add to your notes real quick. My scarf set my board off. I bumped the board, just like Savannah's sleeve. Okay, so kind of just add this last part to your notes or cross off that last example and just write it right in there. It's fine. Then don't. All right, so what, let me rephrase it. So if I ask you what degree polynomial is it? So what degree polynomial? If I give you answers of 7, 3i, negative radical 6, what degree is that? I hear a lot of different answers. I heard quartic. I hear 5, 3. This is quintic. Because if I have 3i, what else do I have? That's plus or minus. This, that's plus or minus. 2, 4, 5 answers. That is quintic. Okay? What if I give you -7, 0, 5, negative radical 3, plus or minus 4i, and 6i? It is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 9th degree. On your assignment tonight, the last 2 questions are like this. And every year, somebody tries to see this, and they set up all the parentheses, and they start multiplying this together. Please read the directions. I'm not that mean. I promise you I'm not that mean. Okay? They try. So if I give you the last 2 problems, all I'm asking for is what degree is it? Okay? Don't feel like you have to multiply those. Thank you, Lexi. Are we okay?